Hi everyone, this is your math guru. In this video, I'm going to show you how to evaluate the following sigma notation under your number sequence or series. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have given the sigma notation or summation of 3t minus 1 from t equals to 0, that's the starting point, to t equals to 99. A, write down the first three terms of the series, and B, calculate the sum of the series. In order to write the first three terms of the series, we've been given the sigma notation as summation t equals to 0, that's the starting point, to t equals to 99. The Tn formula is 3t minus 1. So writing the first three terms, since we're starting from t equals to 0, so if we have from t equals to 0, we substitute 0 for t in our equation, which is we have 3 multiplied 0 minus 1, close the bracket. That will give us 3 times 0, that's 0, minus 1, and that's equal to minus 1. That will be our first term, or a t1. To find a second term, we have t equals to 1. I'm going to correct that. We've done t equals to 0. We have t equals to 1. That will give us 3. The same formula, 3t minus 1. This time around, the value of our t is 1 minus 1. That will be 3 minus 1, which is equal to 2. That will be our second term. To find the value of our third term, we have t equals to 2. And that will be 3, using the same formula, multiplying 2 minus 1. 6, 3 times 2, minus 1 equals to 5. That will be our third term. So writing out the terms, the first three terms, we have it as t1, that's minus 1, plus our t2, that's 2, and our t3, that's 5. For the second part of the question, it says calculate the sum of the series. We first of all need to determine if it's an arithmetic series or a geometric series or a quadratic series. We have a series, or the first three terms from our first part of the question, as minus 1, the second term 2, and the third term 5, and so on. To know if it's an arithmetic series, we need to find the common difference. The common difference D will be our t2 minus t1, which is also equal to our t3 minus t2. Remember, this is our t1, this is our second term, and this is our third term. So therefore, we have t2 minus t1, that will be 2 minus 1, and that will give us 2 plus 1. Therefore, our D is 3. A quick check will be t3 minus t2 to show that the difference is common. So we have 5 minus t2, which is 2. This will give us 3. So therefore, our common difference D is 3. The first term, as shown, which is A, equals to minus 1. Therefore, the sum of an arithmetic series, Sn, is equal to n over 2 multiply bracket 2a, that's the first term, plus n minus 1 multiplied by the common difference, close bracket. Now, to figure out what our n is, note that the term t starts from t equals to 0 and ends at t equals to 99. Therefore, the number of terms, our n, is equal to 100. Let me give you a quick illustration. If I have t starting from 0 and the last term is t equals to 5. In order to find how many terms I have here, it will be 6. If I write down the terms for t equals to 0, t equals to 1, t equals to 2, 3, 4, remember the upper limit or the last term will be t equals to 5. How many times do I have? I have 1, 2, 3, 4, 5, 6. So because I'm starting from t equals to 0, my term will have one more, which has been given here, 99 plus 1, which is 100. So going back to our sum, it is important to note where our lower limit or the value of our t or whatever the variable used is starting from. So putting back or putting in the parameters, I have S100 equals to 100 over 2 in bracket. Our first term is minus 1, so I have 2 multiplying minus 1 plus 100 minus 1. A common difference, 3, close bracket. S100 will be 100 divided by 2, 50, in bracket. 2 times minus 1, that's minus 2. 100 minus 1, that's 99. 99 times 3, that's 297. So I have plus 297. That will be 50 times minus 2 plus 297, that's 295. Therefore, our sum for the series given will be 14,750. Let's look at another example. For the second example, we have evaluate the sigma notation or the summation of 2n minus 4, where n start from 4 and ends at 70. We need to find the value of our series, that is the value of each term. And we do that by calculating from n equals to 4. So if n equals to 4, then using the nth formula to n minus 4, we have 2. N is replaced by or with 4 minus 4. That will be 8 minus 4, which will be 4. That's the value of our first term, T1. If n, the next integer, n equals to 5, then using the same formula, we have 2 multiplying 5 minus 4. 2 times 5, 10 minus 4. That will give us 6. And that will be our second term. I need one more term in order to determine if it's a common ratio or a common difference. So if n equals to 6, then I have 2 multiplying 6 minus 4. That will be 12 minus 4, and that's 8. That will be my third term. So my terms are, or my first 3 terms are 4 plus 6 plus 8 plus, that goes on. Remember, this is our term 1, this is our second term, and this is our third term. In order to determine what a common difference is, our D is equal to T2, the term in front, minus the term behind. That should also be equal to T3 minus T2. That's our check. We have T2, which is 6, minus T1, 4. So therefore, our common difference is 2. The quick check is 3, or T3, that's 8, minus 6, that will give us 2. So yes, our common difference is 2. Also, the first term, A, equals T1, which is 4. So using the formula Sn, the sum of arithmetic series equals n over 2, bracket, 2 times the first term, plus n minus 1d, that's the common difference. Note that, like we did in the previous example, we need to note our starting point for, or our lower limit, that's n equals to 4, and our end point, which is 70. Therefore, to calculate our n, that will be n equals our upper limit minus our lower limit, that's 4 plus 1. That will give us 67. And putting that back into the equation, remember the last one we did, if our n is starting from 0, then it will have been 70 minus 0, that's 70 plus 1, that will be 71. But our n is starting from 4, so it's 70 minus 4 plus 1. Therefore, putting that back into our formula, we have S67 equals, our n is 67 divided by 2, in bracket, 2 times our first term, a, which is 4, minus n minus 1, that's 67 minus 1, multiplied by our common difference, 2, close bracket. That will be 67 over 2, in bracket. We have 2 times 4, 8, minus a quick correction. This is a plus, not a minus. We have 67 minus 1, that's 66. So I have that as 66 multiplying 2, close bracket. That will be 66 times 2, that's 132 plus 8, that's 140. Therefore, our S67 is equal to 140 divided by 2, 70. 70 times 67, we have 4,690. Let's look at one more example. In the last example, we have sigma notation or summation of 5 times 3 to the power of k minus 1 from k equals to 1 equals to m is equal to 65. What is the value of m for which this summation or sigma notation is true? Okay, I've adjusted the question. I'm going to read that again. What is the value of m for which the summation of 5 multiplied 3 to the power of k minus 1 from k equals to 1 to m equals to 65? To start with, I need to find the first 3 terms in order to help me determine if it's arithmetic series or a geometric series. So I have, if k, since k is starting from 1, that's the lower limit, I have if k equals to 1, then my first term will be, I'm going to slot in k equals to 1. I have multiplying 3, then k is 1, so that's 1 minus 1. That will give me 5 multiplying 3 to the power of 0. Any number or variable to the power of 0 is 1, so 5 times 1, that's the same as 5. And that will give my first term. If k equals to 2, I have 5 times 3 to the power of k minus 1, that's 2 minus 1. That will be 5 times 3 to the power of 2 minus 1, that's 1. And that will give us 5 times 3, 15. That will be my second term. And if k equals to 3, I have 5 times 3 to the power of 3 minus 1. That will give me 5 times 3 to the power of 2. 3 squared is 9. That's 5 times 9. So therefore, I have that as 45 T3. So now that I know my first 3 terms, I'm going to write that out as my term 1, that's 5. This will be my T1, T2, and T3. Note that if I'm to find my common difference my common difference is supposed to be D equals T2 minus T1, which is also equal to T3 minus T2. T2 minus T1, that's 15, minus 5, that will give me 10. My check is T3, that's 45, minus 15, that will give me 30. The difference, they're not the same. So therefore, I'm going to try my common ratio. To find my common ratio R is equal to T2 divided by T1, and the check is that must be equal to T3 over T2. I have T2 over T1, that's 15 over 5, and that will be 3. The quick check is T3, which is 45, divided by 15, and that's 3. So yes, my common ratio is 3. So I have R equals to 3, and my first term, which is also my T1, equals to 5. Therefore, because the value of my R is 3, which is greater than 1, the formula to use for my Sn will be the sum equals A Rn minus 1 over R minus 1. And if I put in the values, remember my n in this case is m. To find my n equals my upper limit, which is m. In this case, as shown, my lower limit, my k starting from 1. So therefore, calculating the value of my n, I have n equals m minus my lower limit, that's 1, plus 1. And 1 minus 1, that's 0. So therefore, my n is equal to m. If I replace that, I have sum of m, which is equal to my first term a, that's 5, in bracket 3 to the power of m minus 1 divided by r, that's 3 minus 1 must be equal to 65, as shown in the question. Therefore, if I solve, I have 5 bracket 3m minus 1, 3 minus 1, that's 2, equals to 65 over 1. If I cross multiply, I have 5 in bracket 3m minus 1 equals 65 times 2, that's 130. If I divide both sides by 5, I have 5 here, 1. So therefore I'm left with 3m minus 1 equals 130 divided by 5, that will give us 26. Moving my minus 1 to the other side, I have 3m equals 26 plus 1, that's 27. I need to put them in the same base. That will be 3m equals 3 to the power of 3. And because the base are the same, the powers will be the same. So therefore, my m equals to 3. Thanks for watching. Bye.